Okay, today I'm going to teach you about forward bias resistance questions in diodes. Now, this is one of the toughest questions in diodes, which is not being given most frequently. So, this is the question we are going to discuss today. In this question, you can see there are two diodes, and they say they have a forward bias voltage or the barrier voltage of 0.5 each and a forward bias resistance of 5 ohms. And there's an ideal voltmeter, and they're asking us to find the reading of the ideal voltmeter. Right. So let me explain the theory part first. So as you know, there are two types of diodes. One is ideal diode and the other one is the practical diode. So in the ideal diode, in reverse bias, it does not allow any current to flow and under any circumstance. But in forward bias, it allows any current to flow without any potential difference. So මෙන්න මේ වගේ එකක් තමයි අපිට ideal diode එකේ එන්නේ. forward bias එකේ කිසිම current එකක් යන්න දෙන්නේ reverse bias එකේ කිසිම current එකක් යන්න දෙන්නේ නැහැ. forward bias එකේ ඕනම current එකක් යන්න දෙනවා without any potential difference. Right, you know this. දැන් ඔයගොල්ලෝ මේක දන්නවා. And if you take the practical diode, in the practical diode, let's take a silicon one. In forward bias, if you give a potential difference of 0.7, the barrier voltage, and then a current begins to flow. And in reverse bias, there's a leakage current and there's a breakdown voltage, or you call it peak inverse voltage. And at peak inverse voltage, it breaks down and a current will be flown. So you need to have at least 0.7 volts given in forward bias to send a current through this diode. Right. මේක ඔයගොල්ලෝ දන්නවා. හැබැයි ඔයගොල්ලෝ practical කියලා ගණන් හදන්නේ මේකට නෙමෙයි. Because this is scenario number 2. ඔයගොල්ලෝ ගණන් හදන්නේ මෙන්න මේ වගේ එකකට. practical diode කියලා ඔයගොල්ලෝ ගණන් හදන්නේ මෙන්න මේ scenario එකට. Right? So if you get 0.7, you can send any amount of current. මේක තමයි සාමාන්‍යයෙන් තියෙන්නේ. But this is the exact graph which shows us an inclination. So in VI graph, if you have an inclination, I is equal to 1 over R into V. So if you have an inclination or if you have a gradient, that means you have a resistance. Now this is called the forward bias resistance, right? So the question is asking about this. මේ ප්‍රශ්නේ අහන්නේ ඔන්න ඕක ගැන. සාමාන්‍යයෙන් ඔයගොල්ලෝ ගන්න හදන්නේ මේ විදිහට. ඉතින් ගොඩක් දුරට ගණන් ඔයාලට හම්බෙන්නේ මේ practical diode scenario 1 එක එහෙම නැත්නම් ideal diode scenario එක. But in this question, what you have is the practical diode scenario 2. So in this question, let's first think that there is no current passing through any of the diodes. If so, there'll be a potential difference of 10 volts here and here. So then we can think, no, there should be a current. Yes. So both diodes are active here. So there are two currents passing through the diodes, I1 and I2 කියලා ගන්න පුළුවන්. And the total current here will be I1 plus I2. And there is no current through the voltmeter as it is ideal. So it's just measuring the voltage. Right. Then අපි මේකට Kirchhoff දාමු. Right. So let's apply Kirchhoff's second law to this loop. Sigma A is equal to sigma IR. So there's a 10 volts battery and there's a current I1 plus I2 passing through the 10 ohms. So 10 times I1 plus I2 plus Here's a potential drop of 0.5, which is the barrier voltage. එනම් 0.5 එකකුත් මෙතෙන්ට දාන්න. Plus there's another 0.5, another 5 ohm resistance in each of these diodes. Right, diode එක ගැන අපි මෙහෙම ලියමු. 0.5 volts and 5 ohms. Right, so I have written 0.5 and there's a 5 ohm resistance, so it's 5 into I2. So when you simplify this, you get this equation. Okay, now let's apply the same Kirchhoff's second law to this loop as well. Make it down. Sigma E is equal to sigma IR. So it's 10 equals to, so it's 10 times I1 plus I2. And there's a potential drop in this 0.5 plus there's a 5 ohm, another resistor, and also you have another 5 ohm in this, so it's 10 ohms, 10 into I1, 10 into I1. Right, so let's simplify this also. 9.5 equals to 20 I1 plus 10 I2. Okay, so we have two equations. So what I'm going to do, I'm going to multiply the first equation by 2, and I'm going to deduct second equation from it. So when I multiply the first equation by 2, I get 9.5 into 2 minus 9.5, so it's 9.5. 20 I1 minus 20 I1 is 0. 30 I2 minus 10 I2, that's 20 I2. Right, so from this, we can find the value of I2. So for I2, you get 0.475 amperes. Right, so when you know I2, now we can find the potential difference here. Then very easy. So there's a potential drop of 0.5 volts plus then the IR product of the 5 ohm resistor. So we can say the voltmeter reading V is equal to 0.5 plus I2, that's 0.475 into 5 ohms. So for this one, you get 2.875 volts. Now, this is the answer for the question. Right, so there is another way of doing it. තව විදිහක් තියෙනවා ටිකක් lazy විදිහක්. Now, if you think more, right, if you think more, there's an easy way. So now I'm going to draw both of these diodes as one. Right, කොහොමද ඒක කරන්නේ? So I'm going to simplify it. Now both of these diodes, මේ diode දෙකේම තියෙනවා 0.5 potential drop එකක්. එහෙනම් ඒ 0.5 potential drop එක I'm going to take it out. Now as it's a drop, I can draw a battery opposing to the battery here. ඒක drop එකක් නිසා මට ওই විදිහට ලියන්න පුළුවන්, right? Okay, now you have a 10 ohm resistor on this side and a 5 ohm resistor on this side. So 10 ohm and 5 ohm, the effective resistance is 5 into 10 divided by 5 plus 10. So you get 10 by 3 ohms. So now you have a 10 by 3 ohm resistor. Hari. Voltmeter එකක් තියෙනවා මෙන්න මේ පැත්තේ, and there is no current passing through the voltmeter and it's measuring the potential difference here. And the current now, දැන් එක current එකෙන්, so I put I. Now you can apply Kirchhoff's and find I. Sigma E equals to sigma IR. I'm applying this to this loop. So it's 10 minus 0.5. අර previous මෙතන තිබ්බ 0.5 එක දැන් මේ පැත්තට ආව minus වෙලා, right? ඉතින් battery එකක් විදිහට දාගත්තොත් අන්න ඒ වගේ simplify කරන්න පුළුවන්. It's an easier method. Right. 10 minus 0.5 into I times 10 plus 10 by 3. 10 plus 10 by 3. 10 plus 10 by 3 is 40 by 3. So I is equal to 9.5 into 3 divided by 40. And that is 0.7125 amperes. Okay, then අපිට wattmeter reading එක හොයන්න පුළුවන්. V is equal to, there's a drop of 0.5 and there's another drop through this resistor. So it is 0.5 plus 10 by 3 multiplied by 0.7125. And when you simplify this also you get 2.875. ඉතින් මේක ටිකක් ලේසි විදිහක්. Right? So again, this type of questions, they don't come more often. Right? මේක තමයි diodes වල අමාරු question type එක, food bias resistance තියෙන එක. So there are not actually two graphs, there are three graphs, one for ideal and two for practical scenarios. ඔන්න ඕක තමයි ඔය graphs වල වෙනස. So always go with the graphs when you are doing questions like this.